Hi everyone. So let's do today's daily Giants question. The question is maximum matrix sum. Okay. What is the question? Let's read it. As usual, set 20 minutes timer. What is the time? It's taken already. Oh, okay. So you are given an n times an integer matrix. You can do the following operation any number of times. Choose any two adjacent elements of matrix and multiply each of them by -1. Okay, so I can do this operation anytime, any number of times. So if this is a matrix -1 1 -1 -1 1, then I can choose any two adjacent elements of matrix. What does two adjacent mean? Is diagonal also adjacent or not? I think it is adjacent, right? 1 -1, two elements are considered adjacent if and only if they share a border. So yeah, I don't think adjacent, I don't think diagonal is an adjacent because diagonal because because diagonal it they don't share a border. Yeah, border means it should be like this. Okay, so I can take any two adjacent elements of the matrix and then multiply it by -1, so -1 and 1, and then again I can take this 2 and multiply by 1 -1 again. So my goal is to maximize the summation of the matrix elements. Okay, so if everything is this, I need to maximize the sum of all the matrix, right? Here in the maximum sum of the matrix elements using the operation mentioned above. So here it will be 4, right? So here, so 1 2 3, let's try doing this. 1 2 3, and it is -1 -2 -3, 1 2 3, 1 -1 -2 -3 and 1 2 and 3, right? 1 2 3 1 2 3 -1 -2 -3. Okay, now what? So my goal is to maximize the sum. So if I sum the elements of all the elements of this matrix, the sum should be the maximum, right? And I think the sum will be maximum if it is positive. So n is equal to matrix dot length is equal to matrix I dot length. Yeah, it is a square matrix and n can be from 2 to 250. So it can be 2 by 2 or 2 to 50. So it can be negative and positive both. So I think that my main so what can I do this to maximize the sum? 1 2 3 -1 -2 -3 1 2 and 3. What can I do? What can I do? What can I do? Here. I think that the biggest thing that I can do is to convert negative to positive, because I cannot change the number, right? I cannot change 1 to this -1 to minus, I cannot change 1 to 4. I can only change it to positive. So the biggest thing, I mean, the maximum sum, it means that if as much as numbers are positive, then so here I can see that 3 elements are negative. So how I'm trying to see how can I make all these numbers positive. Okay, so these two share a border and these two also share a border, but if I do minus here, then this will be positive. Okay, this 1 and 2 will be positive, but -3, right? So I think that here what I can do is, instead of doing 1 and 2, making 1 and 2 positive, what I can do is I can make -2 and 3 positive. so that the bigger elements are positive, you know, instead of the smaller number. Yeah. So attend maximum positive numbers, and while making positive, while making negative to positive, target the larger numbers. Okay. Yeah, so I can do only this, right? So it will be -1, 2 and 3. Other than that, I cannot do anything. So the maximum sum will be 1 plus 2 plus 3, -1 plus 2 plus 3 plus 1 plus 2 plus 3. Yeah, it can only be that way. I'm thinking if there is another way. No, there is no any other way. There are three. There are all these numbers. They are negative, and I need to convert them to and sum. For creating the sum, it is only possible. Yeah, the sum is highest only if all the numbers are positive, right? And especially, yeah, bigger numbers. So I cannot make everything positive at the same time, because I can only make two numbers positive at the same time. And yeah, so if I have to choose two at the same time, I choose this. So it will be multiply the two last elements by -1. Yeah. So what can I do? Let's look at another example. So what if this was this? What if this was not this one, but yeah, like this? Then what could I have done here? Then here this is -3 and its adjacent is 2. So I think what I could have done is make this -2 and then this +3, because this is smaller, right? So this is bigger. So if I find any number less than this, then I can just make it negative. I can make it positive, and this whatever. Yeah. And I can say that okay, these two numbers are also negative, so I can make it positive now. Wow, everything became positive now. Interesting. But what if this was the case? Then what could I have done here? So -1 and 2, and I could not do 1 and -2 here, right? Because I'm making another thing negative. I'm just trying to see if I could solve this using greedy approach, But instead of greedy approach, will I have to do try everything like dynamic programming, something like that? I do not like such solutions. I just like if there is some dynamic greedy approach, straight solution, like if I have to try and find all the possible solutions, then that is very, I don't like such things. But I think this problem, to me it looks like that. Looks like I need to find all the possible things, because greedy, it is not like greedy is possible, I think, if I first go look at the biggest number. So suppose this was 4, and 3. Okay, so if I look at the biggest number first, I think that is possible. So if I look at the biggest negative number, then okay, this is -4 and I can make it positive or not. I can decide if I want to make it positive or not by looking at its neighboring numbers. So if any number is less, then I can just make it positive, right? Yeah, so I can make it positive with this one, -2. Yeah, and then again -2 I can make it positive by using this 2 and -1, and then negative here. Yeah, so if I start from maybe the biggest number, then it is possible. Biggest negative number, Yeah, but if I do that, if I just find what is the biggest, what is the smallest, then it will take too much time. I just want to look at the solution, I don't know why. Sorry. Journey from minus to plus. To maximize matrix sum, let's imagine if every element were positive, then we can flip the elements. So we need to think our flipping does not work perfectly. Since we can flip pairs of atoms by multiplying them by -1 makes positive, so we start calculating the sum of the absolute values of all elements, as this would be the ideal maximum sum if all elements were positive. Yeah, that's true. Next, we need to think about when flipping does not work perfectly. Specifically, if there is an odd number of negative elements, it won't be possible to make everything positive because one negative will always remain. This observation leads us to a simple rule: if there is an even count of negative numbers, we can flip them all to positive values. But if the count is odd, one number has to stay negative. So to minimize the impact of remaining negative, we want it to be the smallest number of the matrix. So while calculating the absolute sum, we also track the smallest absolute value. This way, if we end up with we can subtract twice. The subtraction accounts for what? Really? Is this the only solution? But I think I did not understand the solution yet, but looks like solution is very straightforward and it is not dynamic programming or recursive or anything, so let's try to solve it. So I think that what I got a hint by looking at that is, if it is -4 and then -2, am I streaming, right? Yeah, stop streaming. So yeah, so if it is -2 and -4, or suppose if it is -4, okay, and then it is possible actually 4 and then -3 and then again -3. Yeah, actually it is possible to just rotate, so this can go, because I can do -3 3 3. So I think this is the biggest thing that I missed. So see, if this is 4, then I can shift it anywhere. I don't just have to look at the adjacent ones. Yeah, so if it is -4 here, then it can go anywhere. This 4 can, this negative, so if I transfer here, then I can transfer here. It can be transferred anywhere in the matrix. So that is the biggest thing I should have thought about. Yeah, now I thought about that, but still I should have thought about that in the beginning. This is the biggest thing. So this negative value, it can just transfer anywhere. Okay, and since it can transfer anywhere, this -4 can transfer anywhere. So suppose if it is 1 and suppose this is -3, okay, and this is -3 -4, so this -4 can transfer here, and 3 can go away. So see, if there are two negatives, then it can go away even if that negative is far away, you know. So this is the takeaway. If two negatives, then they can cancel each other. But if only one negative, then it can traverse to get to it can traverse to transfer its negativity to transfer its negative to any smallest number, you know. Yeah, isn't it? So if it is negative, then it can go anywhere. It can go first of all here, then here, right? So because this one is the smallest element, and then if there are two negatives, then it will cancel each other. Similarly, if there are four negatives, then two negatives will cancel each other, two negatives will cancel each other, like that, right? So if this is negative and negative, so it can go and then cancel this. So suppose if there are three negatives, then only two negatives can cancel. Yeah, so I think what I mean is here is it means that if there are odd number of negative elements, then there will be one negative remaining. But if there are yeah, it will cancel out if there are so take away. So it means if odd number of negatives, then it will even will cancel out each other, and even negatives cancel each other, and one will be left, right? Yeah, I can show example. So even like if there is some even number, then it can cancel each other, you know. So this -4, so negative will be transferred here, then this and this will cancel, and this is negative, so it can go here, and this can cancel. But if there was one negative remaining, then it cannot cancel anything. Yeah. So that is why I should just first count how many negatives are there, and I can just so solution is, what I can do is I can just traverse matrix and count and get these two things. First, count of negatives, and two maximums and two minimum. Count of negative and two minimum number, you know, the smallest number, minimum absolute number. I mean if even if it is -1, then one is minimum, you know. It's okay if it is negative. So if I do these two things, then get count of negatives, minimum absolute number, then get count of negatives, minimum absolute numbers, and then I think what I should also do is get matrix sum as well, because I need to get the sum, right, by taking all as absolute values. Okay, and then at last if even negative, then answer is matrix sum. Otherwise, if it is if all number of negatives, then what I'll do is I have to do matrix sum minus the minimum number. Yeah, that's it. So let's do it then. Yeah, this is it, right? I think this is it, because any two adjacent numbers, it can be, yeah, it can be, because I'm just trying to foolproof verify that this is the solution. So okay, so it means, so any two numbers I can multiply by -1. It means that I can transfer it, I can transfer this negative anywhere if I can do -1, you know. This means that, so if I can transfer it anywhere, then obviously I can transfer it until, you know, so this, if this is negative, and then if I can, then this will cancel each other, right? Yeah. Okay, I think this would work. So negative, 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 negative will cancel each other. It can travel, negativity can travel. Negative, 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 yeah. I think I would have come up with this solution if I had created more examples. I should have done that. If I had created more examples, then yeah. Okay. So let's do this. Let's traverse the matrix. So let matrix sum is equal to 0 in the beginning, and let count of negatives is also 0 in the beginning, and then let minimum number should be ouch, minimum number should be so it can go until 10 to the power 5, right? So if I want to do math dot minimum, then it should be maximum, so that number dot infinity or something like that, number dot positive infinity, you know. Number dot positive infinity. Okay, JavaScript, I can do that. Why is it taking such a long time? Okay, so now for let I is equal to 0 as less than matrix dot length I plus plus, for let I'm just traversing the matrix 0, j is less than matrix dot length because it is n times n matrix, j plus plus. So first row, first column, so matrix I j will be my current constant, current element, right? So this is my current element, and then what I will do is, first of all, I can just do matrix sum is equal to math dot absolute value of current element, and another thing what I should do is I should get it math minimum number, right? So minimum will be equal to math dot minimum of minimum number, comma, okay, or actually what I can do is instead of doing math or apps, what I can do is um, if current element is negative, then what I can do is I can just increment count of negatives and just say that current negative is equal to current negative, so that I don't have to do. I can just do this because I made this positive, so that I can add it and I can do method minimum here. Yeah, so at last, if count of negatives percentage 2, if it is positive, then so return. If it is even, then I can just return maximum sum, matrix sum. Otherwise I need to return minus minimum number, right? Yeah, so I traversed the matrix, got the count of negatives, got matrix sum here, and got minimum number. And if it is positive, then this will be my matrix sum. Line number 61. Current EL is equal to assignment to constant variable. Oh, okay. Wrong answer. So here there are 3 elements that are negative and then 1. So I can do -1 right here. 1 to 3. Output is 17. So here let's see what is the use test case console.log what is matrix sum and what is minimum number. Use test case and then run. So maximum sum is 18 and minimum is 1. Three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, 18 minus 1 is 17. Okay, so my algorithm is not working here. Why is it not working? So if it is 1, 2, 3, and then if it is -1, -2, -3, and if it is 1, 2, 3, right, then I can just multiply this by positive, right, and then do -1, and then just do and then just add. Oh yeah, actually I need to add it. I need to subtract it 2 times because yeah, that's true, because if it is positive then I need to subtract it 2 times, I think. Or no, what is happening here? Because here I'm, first of all, when I'm doing matrix sum, I'm taking into account everything, right? So I need to minus this, and then yeah, I need to minus this 2 times here. But what if this was the case? What if it was -3? Then so what I'm trying to do is, so if it is 1 and -3, okay, then I would have done 1 plus 3, right? Here I should just do -1, isn't it? 1 plus 3 plus -1. But what if it is -1, 3? In this case I would have done 1 plus 3, right? And then Yeah, I could just do -1 here as well. So if I have sum of all numbers, and I need to subtract one element there. Actually, this would be -1 also, because I need to do 3 minus 1, isn't it? And here it should be um, 1 plus 3 minus 1. Here as well, I think. Right? Because 1 plus 3 minus 1 will lead to 3, but I need to do -1 as well. So I need to do -1 again. I need to subtract it again. I'm feeling very sleepy. It is already 10:26. I have not even cooked. I need to cook and eat and sleep. So 1, 2, 3, and if I, so suppose if there is 1, 2, 3 numbers, okay, and then sum of 1, 2, 3 numbers, but I found out, okay, this is negative number. I found out that this is negative, then I have to, if I know that okay this is negative, then I have to subtract it -1 to return this, and then do -1 again, right? But what I did not understand is how did it work before. Yeah, I mean, thank you. I should do two times, but why I was confused is why did it work for so many test cases? That's why I was trying to re-verify this 2 times. Oops. And this was a really, okay everyone, thank you very much for watching. Bye bye. Yeah, and I think takeaway here is just try to understand what the question is saying. Because if it is saying two adjacent numbers, it can be multiplied by -1, then it means um, it means I can transfer negative to anywhere. And if I can transfer negative to anywhere, then there are a lot of possibilities, like cancelling each other. Yeah, this is really good question, tricky question. I don't know how I could have come up with this trick in the beginning. Maybe, like I said, I should have looked at more examples so that I could have understand what the problem is saying. Or just try, or if I had just try to visualize the problem, that negative cancels, and so just try to understand the problem first. Try to understand what the problem is exactly trying to say. Yeah, and just visualize and be very comfortable with the problem. If I'm comfortable with the problem, then if I know what it means, then the solution will come, right? If I knew that negatives can cancel and can go anywhere and it can cancel each other, then the solution was so easy, etc. Okay, so time is up. Now I will go cook and come up with another video and then eat and sleep. Okay, bye.